with or without anyone, but it is always a fun to code if you have a certain task and you want to really do coding to solve that task. Till now, everything was good. Okay, so Kansha is saying that everything is good. I was familiar with R before. I self-taught. Okay, deployed. It was good to have a step-by-step tutorial for a deeper understanding. Okay, great. Okay, so maybe what we can talk is right now, maybe before going for coding, what is linear regression? Okay, so maybe somebody can raise your hand and say, because let's make it a little bit more interactive, but just avoid chaos. So just raise your hand if you know what is linear regression. So I'm looking here that if somebody is raising hand. Yes, no, what? So all of a sudden, nobody is saying anything, trying to find the best fit. Okay. Okay. It's okay. Whatever you think, you have any kind of idea about the linear regression, reducing dimensions. Anyone else?
The relationship between the independent and dependent variable, and you can.
So you want to say that the relationship between the dependent and independent variable.
Yeah, and how both of them interact, and how about
Yes.
the.
Yes, you are very close. Great. So Devdut is also saying that linear relation between variable, independent and dependent. Uh, Rippley also saying relation between two variants. Okay, two variables. In fact, it's statistical approach for modeling relationship between dependent and one or more independent variable. Okay, all good. Yeah. So yes, so when two variables are related, that relationship could be of many types. Okay. Now, one type of relation is saying that one variable is linearly dependent on another variable. Okay. Okay, guys. All of you are correct. Now, let me talk a little bit about linear regression. So, I'll not put lots of effort on this because I think you already know it, that what exactly it is. Uh, but once you have a very good understanding of what is linear regression, then only you will be in a condition to use it properly. Okay, so for any kind of application, you have to understand the concept also. So when we say that the linear regression or the regression, so it's a relation between two variables, and when the relation is linear, we call it as a linear regression. It could be non-linear, right? It could be polynomial relation. It could be exponential relation. It could be logarithmic relation. All kind of relations are possible, right? And and then later on, what people have done is that they just go to one step ahead and they say, I'm not able to find out how exactly these variables are related, but I believe that there must be some relation. Okay. And then people started using very complex mathematical relation, and they call it as a machine learning. Okay. So that is how, how you define machine learning. So it started all from the linear regression. Believe me, that's everything started from the linear regression, where people establish, and it's very easy to establish a linear regression or linear relation. But the moment you go to non-linear, it becomes a bit more difficult. When you go to multi-linear or multi-non-linear, it becomes much more difficult. But even when you go to the machine learning, it becomes very complex. But the power of the machine learning is that it can handle lots of variable. Okay, it can easily handle lots of variable. And then the next thing that machine learning can do is that it can extract something very meaningful, which you may not be able to extract if you just seeing the data or trying to, because our mind works very similar to linear regression. Okay, I mean, we can always say that if this one increase, this one also increase, this one decrease, that one also decrease. So something like that. But if the relation is, and not necessary that every time you get this kind of relationship, right? Sometimes your relationship is much more complex, right? So when the relationship is much more complex, you go to linear regression or you go to machine learning. Okay. But I hope relation should be very simple, and it can be solved by linear regression. Now, in linear regression, we have two kind of, two categories. One category is a single linear regression when you have only one independent variable. Now, this is the simplest one, but the thing is, maybe that single independent variable is not able to tell you the complete story about the dependent variable. Suppose your dependent variable is um, income of any person, and your independent variable is age. Okay, there is some kind of relation. Of course, there is some kind of relation between age and income. One can expect that, once you go up in on the age bar, your income may also go up, but it doesn't go all the time, right? It doesn't happen all the time, and for many people, it doesn't happen at all, right? And then after a certain age, it can drop also, right? So maybe you can set up a linear regression, single linear regression, single variable, but that relationship won't be very strong, right? Now, if you want to make a strong relationship, then what you will do? Tell me. Yes, I'm going close to camera so that somebody can hear me. Somebody can say something, or write whatever. So suppose this is a very common example. So all of you can think about it. You got my question? Why there is pin drop silent? Take multiple variables. So Ishfaq is saying, Devdut is saying, repeat please. Okay, let me repeat. So what I'm saying is, so guys, please listen me. This is just 1 hour, okay? And after this 1 hour and before this 1 hour, you all are free. So what I'm saying is, suppose age is one variable, and you need to establish a relationship of age with income. But the relationship is very weak, right? Because age might not be able to tell you very accurately about the income, right? So what you will do, if you want to make this relationship bit stronger, or you want to predict income of any person accurately, then what you will do?
Add new
Sir, Devdut here. So in that case, add another variable like education or education qualification, like that.
Right?
So,
Yeah, Devdut, I got you, and you all are correct. I knew it means it's just geographical location. Yes, of course, geographical location. I mean, this could be very interesting, right? I mean, if we take some sample from India, some sample from Germany or UK, US, Australia, and then see that, and there is also a data. I mean, of course, and age, and then what is the education level of the person. Does gender also affects it?
Yeah, there's a there's a gap between salaries.
Yeah, unfortunately.
Then.
Yeah, so unfortunately it is. So once you collect all these kind of data, and then you can establish a relationship. And this is very interesting to solve it. And then you can, in unknown scenario, if somebody gives you all the data, you can predict the income, right? You need not to ask that what is your salary, which is of course not good thing to ask. So let me now share my screen. Okay, so this is just a brief about how the regression or the relationship works in mathematics, of course. Okay, so hope all of you can see my screen. Anything is hidden from my screen, or everything you can see it?
You can
Entire
all see the article.
Okay, you can see that. Okay. So let's start. For today's session, we are going to use the file which is called outsmiles.csv, which you already have it. Okay. So first of all, this is like the common thing that we need to do every time when we are coding. So we are saying get WD, and let me know where I am. By the way, there is a command which is dir and bracket. It lists all the files wherever you are. Okay. So by the way, I'm not sure if my outsmiles file is here or not. Maybe it is not here. So I'll go to desktop. I will use this graphical interface to change my, though I don't use it, but you guys can make mistake in writing the path. So set working directory and go to directory. Let's say, I think my file is in desktop, and I say open. And now if I run this, I have a path here saying desktop, and then I have dir just to check that my outsmiles file is here or not. Yes, it is. You can see that. So it is listing all the file, of course. Okay. So if it is not here, if you don't see your file here, maybe you won't be able to read it in a simplest way, right? You can read it. You have to give a complete path. So let's say data is equal to read.csv. I mean, I would have enjoyed a lot if it would be a, physical class or classroom kind of thing where I can see your laptop, how you are coding and where exactly you are. But then we have to limit, lots of things like not so many people can participate, not so many people from different geographical region can participate. But of course, everything has some limitation. So data is equal to read.csv as I have written, and then out. This thing we have done so many times. And then we just view the data. Okay. So we view the data. And on the data set, what you can see is the first line is smiles. Smiles, I think if you guys know it, it is just a chemical representation, a single line chemical representation of a molecule. So you can represent your molecule as smiles. And then we have PIC50. So it is minus log of IC50. So what is IC50, guys? You know that? What is IC50? Yes, I'm looking.
It is inhibiting at 50% of dose, I think.
Okay. Go slow.
Inhibiting concentration,
Ah.
which will 50% of the drug dose, which inhibit the growth of a bacteria, or you can say
Okay.
that.
Okay. I think it is slightly different. I mean,
amount of drug.
Yes, good.
Amount of drug required to inhibit the
Yes.
the target and all by 50%.
Absolutely correct. Yes. So amount of the drug, or you call it as a concentration of the drug, which is required to inhibit the activity of something by 50%, right? Anything like it's a protein, it could be a bacterial growth, viral growth, right? So the activity is reduced by 50%. And for reducing that activity, how much drug you want? So tell me, guys, do you want a high IC50 for your drug or low IC50 for your drug? Low? Okay, so everyone is saying they want least concentration, minimum concentration to do that. And all of you are correct, right? So I'm not going into that. It means that, yes, you know that. Now, suppose I have a set of these 35 molecules, and I know by experiment that these are experimental data, IC50, and people have done some experiment in the past, and they found that, okay, these are the IC50 for my drug. But suppose tomorrow or later on, I come up with some new molecule, okay? Now, one way to find out its IC50 is, of course, do the experiment. But it's not so easy to do experiment for, let's say, 1,000 of molecules. Maybe one molecules you can do it, but if it is 1,000 in numbers, you have to be very rich, right, to carry all the experiment. But in that case, your prior information can help you out. Like, this is your prior information that that these 35 molecules has this IC50. Okay. Now, what I will do is I will calculate some of its properties. So all the other columns are properties. Okay. So if you guys interested, I'm just writing the name of the software, which is called Paddle. Okay. This is called Paddle. And Paddle can calculate the property if you supply it smile file or just a smiles. It will calculate all the property. And this property I have calculated using smiles. So I calculated all the property for my compound for which I have IC50. And now what I will try to do is I will try to establish a relationship between my property and my IC50, right? And if I can establish a good relation, then in future, if I come up with 1,000 of new molecule, I just need to go to Paddle, calculate all the properties again, and feed it to the linear model which we have developed. And that's it. And it will give me the predict the IC50, right? And no need to carry the experiment. So this is, you got that? Everyone got this thing? What I just mentioned or described or explained? Yes, I can see that. Yes. Oh, okay. And by the way, do you know by any chance that what this whole process is called? Some of you might have heard the name. Now, this is not ML. ML is very general, but the activity, okay. So one person said QSAR, another also said QSAR, and yes, of course, this is called QSAR. Okay, so this is called quantitative structure activity relationship. So once again, we are doing the same. Okay, now come back to the code and we view the data. We understood the data. Of course, you need to understand the data. If you don't understand the data, how can you do it? Any analysis. Okay. Now, suppose you want to find out that, okay, what are there are how many columns? I have lots of columns in my data set, and to know the dimension of my data frame, the command is dim. It stands for dimension. Okay, and dim, and we say dim data, and that's it. So dim data is saying what it is saying, 35 and 1446. So these are the number of the rows and column. Okay, got that? Okay, so there are lots of columns, guys. Okay, Now, there is something called very important in machine learning, more important than machine learning itself, is pre-processing of data. Okay. Now, in pre-processing of data, if you don't do the pre-processing, you will get entirely a different result. First thing is, there are lots of things that you can do in pre-processing, but we are going to cover some of the essential, most essential one. And the first thing is removing blank or NA. You can do it manually also, okay? Or in this case, because we have lots of columns, so I will just remove the column where we have any NA, because then it can create some problem at the end, okay? If it has one blank for one data points. Then the second is removing the column with all same value, okay? It means constant column, okay? Constant column. And last is remove correlated columns, because you don't need correlated columns, okay? You need data which is saying different story, right? Like the age of a person and let's say education. These are entirely different information. So you need this kind of information. Now, if age of a person, education of a person and maybe degree or something like that will tell you the same story. Why we have to give space between serial numbers? Where is that space? No, that is all comments. These all lines are comments, guys. We are not doing any coding. This is just to make you understand. You can see that all these are in green. So these are comments. Don't worry about that. Okay. Now, what I'm going to do is all these three steps are very important, and you are going to use it every time, almost every time. Okay. Now, how you can remove those column, doctor? Why we need to remove the column instead of replace the column? Yeah, you can, Diana. You can of course do it, but that is a little bit could be more challenging at this stage, looking at the crowd and everyone. But of course, this could be the another option, that instead of deleting the whole column, you replace or you put, and that is called imputing, right? That you impute that value with mean or median, okay? And that's why I said there could be many things. Means then you have to see how many NAs. If the NAs are too many in your column, then I would prefer to delete it. If there is only one or two NA, I would just impute with median or mean. Okay, so this is not so objective, but yes, I'm just following something which is very convenient and very well established. Okay, guys, all good? Thank you. Okay, so I'm going to give you a 2-line code for removing NA and removing column with all same value, means constant. Okay. Now, these line could be a bit tricky for you to understand, but you can also write your own code, and this you take it as a homework. Okay. Now, come back tomorrow and show me a code that you read a file and then it deletes the column which has any blank. Okay, can you do that? Okay, so take it as a homework and do it with your logic. But for today's class, I'm going to take the line which I have already written it, and which might looks a bit difficult at this stage. Okay, sorry. At this stage, it would be a bit difficult, but I'll make you understand at least. So I'm saying data, and of course, this I also don't remember. I just coded it once and I keep it with me. And every time when I need to process my data, I run this. Okay. So data is equal to data. Then you should have data and this. So you know that this is how you fetch the element of your data frame. So you are saying blank row. It means every row, right? Now on column, you need to apply some condition. So there is something called apply. Okay. Now apply is a function which inside this, you write some code and if you want, it can apply the same code on the every element of your column or every element of your row. So apply is like that. You write once and say apply on column. It will apply it on all the columns. Okay. Now I wrote apply. There is an exclamation sign also, but I'll come back to that. Apply and then say data. So I'm applying it on what data? So on data set data. Then I say 2. So 2 stands for column. Okay. So it means saying that you take a data and take its column and apply something. That thing I have not written it yet. So apply this function. Okay. And function x. X is just a variable. And what is that function is? Anything which say is dot na. Okay. Is dot na. So I'm just comparing my x with na and saying that if you compare it with na. Okay. So this whole thing is comparing one element with na, okay, whether it's na or not. Like, so the result of this will be true or false. And then I'm outside it, I'm applying it to every element of my column. That's it. So it will just check all the elements of your column. Yes, it's working. So it will check all the elements of your column and then if it has, and see that whether it has NA or not. If it has NA, then I will say not. So you don't take that column. Okay. So guys, I know that this is just a single liner code for removing NA or column which has NA, but you can have multiple line code which would be easier to you to understand. But if you just want to keep it, I would tell you that just keep it with you, this code. Okay. And whenever you have a data sheet and you want to do this kind of thing, you just apply it and just take all the data and rewrite it back to the data. Okay. So this is like super tricky, but at the same time, please explain the exclamation. So exclamation, yes, of course. So what I'm saying is you take something which is, could you please explain? Yes, function X. So this is function X. Function means I'm creating my own function, inbuilt function. Okay. So this is how you create a function. And inside the function, there is something called X. Okay. Now in this whole function, what I'm doing is I'm comparing the element with NA. If it is NA, means if it is true, okay, so it will return, this function will return true for one element. Okay. Similarly, it will return true or false for other element. Okay. Now, if any, and then I'm saying any, so which means that if any of that element has NA, it will return true. Okay. Now, if it is returning true for one particular column, I don't need it. right? I'm saying I don't need if it has any NA. So that's why I'm just applying or writing exclamation mark. So not that column, right? Exclamation is not, okay? So this is just to make you understand the code. But of course, I 2 stands for column. If you write 1 here, it will go for each rows and then screen like this, okay? Yes, okay. So this is, if you want to choose a column, then it's very easy, right? Then you just go and take the column and go for loop and check everything. If you find any NA, just remove that column. So for one column, it's very easy. It is tricky when you have multiple columns and you want to check all of them in one row, right, guys? Okay, but the task is, don't take it very lightly, because sometimes I'm very strict. So why don't you just write your own code to remove NA or remove a column which has NA, okay? But meantime, you can use this one, right? Will you guys write it or not? If you won't write, I will not expect then. Will you write your own code for this? Yes or no on chat box? Yes, so just one yes. Dipti is also ready. Tanveer, Rohan, Naveen, Nines. Okay, guys, great. And just do it. Just do it this. And in fact, if you want, you can go another step, which is saying remove the column with where all the constant value. I mean, if you guys can do these 2 things, and of course, it is from whatever we have learned. So it is not outside it. You need not to Google for it. Okay. So whatever we have learned, you just need to apply your logic and you can do it. And by the way, the hint is that you need to use loop and if and else. You can do that. Okay. Let's see how many of you do it. Okay. And there will be no award or reward, but but of course that will be great for you. Okay. So now the second thing is I'm going to delete a column where all the values are same. Like, the column, the next column, this number of facet always has 0 value. So why to keep it, right? So just remove this. And once again, here also function. And this is something, if you understand this syntax, you can you can use it for many other purpose also. When you have to do such kind of operation that you want to apply something on the entire column, you can do this. Okay. And here I'm saying no, not any is NA, but here I'm saying length of unique, I think unique X is unique X. Okay, guys. So what it is saying is, it is saying once again, taking your data, every row, but only those columns where when we take the unique of that column, okay, when we take the unique, right? So if you take the unique of this column, number of facet, what you will get? How many elements you will get? 1 element, right? Lumi is saying 1, right? So what will be the length of the unique element of this is 1, right? And this is what we are saying, that length unique and this is double equal to 1. So if that is the condition, don't take it. So once again, I'm applying this not sign here, and then I will run the code. But before running the code, I'm just pasting it for all of you. Just copy and paste. Don't LENGTH. Yes. Sorry. Okay. Maybe I can just copy it once again and paste it. Okay. Don't try to write it on your own because you can, miss some parenthesis or some comma or something, and then, it won't work. So just copy and paste. Now, initially when I saw the dimension of the data set, it is saying 35 and 1446. Now I removed all the NA and once again check the dimension. It is still saying 35, 14, 46, which means what? What does it mean? There are no NA, right? Now you do this and then check the dim data. What it is saying? Now it has 35 and 1055, which means what? Now, after taking that, you need something which has all the same value, no constant. We removed 400, I don't know. It's not 400. I think 390 or something. There were columns with repeated value. Yes, there are columns with all the values same, or you should say that there are constant columns. Yes, we remove the constant columns and then it's good. Okay, so you are preparing your data, which you will take it to the next level and say that now I want to do some regression with this. Okay, now the next thing is, okay, both case showing 1055. If the both case is showing 1055, it means that you ran it twice. So can we mention the matching values? Okay, I'm not getting it. So the person who is saying both case 1055, you run it from the top once again, line by line. Okay. Now, suppose I have many columns in my data set, and let's find out what are the names of the column, and these are the names of the column. There are many columns. Suppose I take one column, SIC5, okay? And I want to know that what is its relationship with, so I will use correlation function and saying P, and of course here I will say data dollar PIC 50, comma, and then say data dollar, what was that? SIC, let's say 3. So can you see that the correlation is negative and it is minus 27, minus 0.27, yes, which is not so good, right? It means what it is saying, the relationship of the correlation of IC50 and SIC3 is not so good, okay? Yes, you can say that, Sarath Kumar, you can do that, but right now let's do this. In fact, this one is itself a bit challenging, so let's not go there. But if you want to do, you can try. It won't be too much different from whatever we have done. Okay. Now the thing is, we have 10,055 data set, but I just randomly chosen one, SIC3, and found that the negative correlation between IC50 and SIC3. Now, the better way to do this is to establish a linear regression. And how we do that? So let's say call it linear regression of variable is equal to, the function is called LM. By the way, we are going to perform this third step later on. LM, and you need to say that what is your dependent variable, which is PIC50, and then a tilde sign, this sign, and what is your dependent variable. Suppose I'm taking just one, so I'm making it very simple, and then comma, and what is the name of the data frame, which is data. So this linear R has established a relation between IC50 and SIC3. Okay. Now we will cover some of the graph techniques later on, plotting a graph. So you can also plot it. But right now, if you say summary and the name of that variable that you just created for linear regression, you can see lots of value here. And the one which is most important is multiple R squared, and which is saying 0.07. Okay. So of course, it's not a great relationship. It's a weak relationship because I have just used one data. Okay. So can you guys try it? And this is the simplest linear regression. Can you guys just try it and see that it is giving you the same result? And let me know. Yes, sir, same. So what is your multiple R squared is same? At what point would be interested in adjusted R squared? So see, adjusted R square is not very much required when you are doing any kind of relationship and you are trying to establish any relationship, because people are mostly interested in R square. But more or less, when you see adjusted R square and R square, they are very, very much similar in trend. Okay. There are slight difference in the calculation, but they are very similar. So why we are doing it? Just to find out whether the relation is good or bad. And for that, even the R square is good enough. Means, honestly saying, I have not used adjusted R square till now. Okay. And by the way, there are many other things, but let's not go into the statistic part. There are statistical parameter also. Okay. So for all of you, it is working. Now I will run the last one, which is removing the correlated column. So I'm saying that if two columns are correlated, I don't need it. Okay. So for that, it's slightly, once again, tricky, but the good part is that you can keep the code with you and just supply the data set and it will always do the function for you. Okay, so that's why I'm giving you can write your own code also, but for time being, let's stick to something which I have written. So the very first step that you need to do is you create a new variable, my data, and that is equal to data. And inside the data, I will not take everything. Okay. So what I will do is I will say except the first column. Will it work? I think it will. Because what was my first column? First column was smiles, right? So first thing is I just remove the first column from my data. Yeah. So all numbers, because I want numbers. Now, the next thing that I want is, in fact, this IC50 is also, this is the Y variable. So of course, that is also not of my use. So I'll do that. Just give me a second. Yeah. I think that code is also lots of, parameters in that code. So that also, I mean, I don't need to, I can also do some mistake if I'm going to write it on my own. So what it is saying is, okay, my data is equal to, and you can keep this thing, and this is very important. is my data once again, because I removed that, and then say everything except apply. Okay, once again, a very similar code, my data. Okay. Okay, but we already removed the unique one, right? So this is for the unique one. Okay, so now we are working on the correlation thing, where we are going to remove the data set which is highly correlated with one another. Okay, so let me just take it from my code, and instead of just writing it down, and then I will just explain you that. I don't know if it will work. Just give me a second. I'm just trying it out, that it is working or not. Okay. Okay, so I'm not able to copy it. Okay. I'm not going to, I'm not able to copy it, so I think I have to write it down. That is the only way to do this. Okay. Let me first share the screen. Okay. So I just removed the first column. Okay. Now the next thing is I'm going to say is, let's take a variable R2, any variable, whatever. And by the way, you can always break your commands like in apply, when we are removing all the columns which has same value, there are multiple components. You can always, break your command and run it to understand. So here also we have lots of elements that you can break. So let me first write it down. Okay, are you viewing my data or data afterwards? It won't delete it in data. Sorry, what exactly? Do you have any question, or what? I'm not able to get you what you are writing. Data and 2, before that you say n is equal to okay. I think that chat was not for me. Data and then 2. Okay. So the first thing is you create a variable. That takes the second element of dimension, which is the number of columns. So if you run this and if you print n, it will print 1055. Okay. So this is how many number of columns we have. We taken it in n because we are going to use that. And then we are saying ignore the first column, because in my first column, okay, I'll take the my data, and I will ignore the first column and take it from the next column onwards, second column, till the last column, which is n, right? So this is how we take that. We already know that in data frame how we take the values. And then it takes the correlation. If you say correlation between everything, so it will work like correlation, and you supply the data frame. And then you square it like R square, and you say R square greater than 0.4. So I'm saying that if R squared is greater than 0.4, I will not take it, because then it is more or less very dependent variables, or very related variables, and index is true. So I'm saying that if R squared is greater than, you know, 0.4, first find it out. What are the columns where this kind of condition is true? And that will store in R2. Okay. Then the next, I'm going to say that R2 is equal to R2 once again, and then comma 1 is greater than R2. How do you input the square sign? I just put square and it comes the other square automatically. Shift 6. Oh, that the cap sign, right? You mean the cap sign? Yes, that is of course shift 6. Okay, I think I have done somewhere some mistake. And this is what happens when we have some complex thing. Dot data, dot frame my data 2 dot n. Yes, it is fine. R square. Did I just miss any parenthesis somewhere? Can you guys figure it out? Correlation. I don't think that I missed any parenthesis here. Yes, dim data is taking both the rows and column, but then I'm saying 2. It's data. But I have my data, right? I have my data. I viewed it. Okay, okay. I think here it should be my data, not because now I'm not interested in my data. And then I should use the n for this. Yes, and that was the mistake, because I was using the n of my original data and it was saying that there is no such column, right? Because that has one more extra column. And then this. And finally, the last line saying new data, new dot data is equal to my data and saying only unique one. Okay. So this, yes, somebody wants to say.
Yeah, on line 3, aren't you using the second? No, nothing. I'm sorry, I got confused.
It's done?
Yeah, I'm sorry, I got confused.
Okay, okay, it's fine. So guys, what we can do is here, because if I'm going to explain this code to you, at this stage, it might be difficult. So maybe we can come back to this later on. But essentially what it is doing is, I'm just copy and pasting it here. Essentially what it is doing is, it is deleting those columns which are greater than 0.4 correlation or R square value with one another. Okay. Now in data set, you can always change this 0.4 to 0.3, means you want to relax it a little bit more, or you can make it more. It means you are making it more stringent. You can always play with this 0.4 value. and then it is, if you see this new data is the clean data, and let's view this. So this is the clean data. So all those columns which are not very unique, not very, saying the different story, all these are removed from my data set. So what I will suggest to all of you is these 3 lines and those 2 lines, this line and this line. You keep it with you whenever you want, you can apply it, okay? But I just inserted a couple of lines here also. So I think I should just copy this one and paste it. And all of you guys, just if you have a data frame called data, just run this and see that what it happens, what it says. And meantime, I'm just typing another command, which is new dot data dollar activity is equal to data dollar IC50. That's it. From 21st line, okay. So how about if I, okay, from 21st, I just copy and paste it. I could have done this processing before also, just after removing the constant column. And this is how you should do. But I just wanted you to explain something. So that's why. If it is warning and things are fine, I think go ahead. You know, how you will check that the things are okay. That yes, I think Dinah, absolutely correct. You just check the dimension. What is the dimension of this new data? And it is 3524. But it doesn't have the activity, the Y variable, which because I removed it, right? You remember that? So now I will just put it back, saying that new data dollar activity, I will create a new column activity, and that has the same value as the original data IC50, and then run it. And now if I view new data, I will see the last column as activity, which was not initially there. Okay. Now what I need to do, I have only 24 columns, and I need to just relate it with my activity. Okay. So, okay. So I think I just need to put here a comment, remove. If it is 1055, I think it is not done yet. Remove correlated columns. And this is required. Every time you need to do this. Otherwise, you will get a very weird kind of result. And now let's quickly just give a linear regression. And this time multiple linear regression is equal to LM, which we used just now. And then we say activity, because this time it is activity. Okay, once you add activity column, it will be 25, yes. And then this time I want to take all the columns. So I will just say dot. It means it will take everything. And then data, no, just make sure we have many different kinds of data frame. So the latest one is new dot data. And this, and now if you see summary, linear, yes, and linear MR, and now see the summary, and you will see the R square as 0.80, which is quite high, okay? So what we have observed is that once we process the data and then we try to find a multilinear regression, then it is working absolutely fine. So it means my new data, which is this, all these variables can be used to predict the activity. So this is nothing, this linear R variable is nothing but a QSAR model. This is how we create a QSAR model, okay? So I will just put it something just in a systematic way. The first thing is this, second thing is this, and that's it. So you first remove NA, then you remove all constant value. Then we did some practice thing like correlation and finding the relation. Then we remove the correlated columns, and then we see that how the whole equation improve. Okay, so I'm just copy everything and paste it here from today's session. Now you can copy it. By the way, I'm also going to save it. And today is what? Which class? 4 or 5, right?
Sir, fifth class, your fifth class
Yes.
is.
Okay, so this is from day 5. How you test a test molecule set. Okay, now next time, so this is now from the QSR, which I made.
Sir, your voice is not audible. Dr. Vinash? You are not audible, sir. Wait, don't fill the chat box. We are trying to contact sir.
Hello.
Hello, sir.
Hello.
Hello, sir.
Yeah. Sorry, there was a network problem. Okay, so we almost finished it. So what I will do is I'll just share this today's session 5.r, the 5th session with all of you, and then you go to all these lines. And sir, I'm not having this idea where you please send me for what exactly you want to say.
Sir, I have shared the file in WhatsApp group as well as drive link, CSV file.
Oh, okay. CSV file. Okay. Could you please explain how the multiple linear regression is linked with? So this is, what is QSR? QSR is establishing a relationship between the structure and activity. Okay. So instead of structure, I'm taking the properties, and that's why it is. The properties is also representing the structure. So it is relating all the properties with the activity. So that's why it is QSR. I have understood the codes, Shivani. Oh, that's great. But, for tomorrow's session, you have not understood the code. Okay, don't worry. So which part I think the processing part you have not understood? Is it? Okay, so I think for tomorrow's session, let's do one thing. Let's first, you try to write a code in your logic, which will remove, which will remove all the constant columns and the columns if it is having any in it. Try to write this one. Okay, and Devdut, I think there is some problem. You have not done the processing well, and that's why this is the reason why you are not getting the correct value. Yeah, Confa and those things are very, very complex. So this is at a very initial stage of QSR. So the main, the goal of this session is not QSR. This is on a linear regression. Okay, so I have pasted the code. What you need to do is you need to paste it on a new file and run it one by one. For the processing, the 3 pre-processing that we have done, you first try to come up with your own logic. Okay, and tomorrow, of course, I'll explain again some part of it and go to the logistic regression. Okay.
Sir, is it
Fine.
over?
So can we?
Is it on
Yes,
for today?
I think it's yes.
So sir, will you share our file today or tomorrow? This
No, I'm
file.
going to share this this R file. I'm just straight away I'm sharing with you, Praveen.
Okay.
I think you without, I mean, they should get this R file so that they can practice also. Okay, just wait. I'm sharing it.
And participants, please don't left meeting. I have a little bit announce for.
Okay, you announce whatever Praveen you want to go ahead, please.
So,
I shared the file with you now.
Okay, sir. So, participants, you will be glad to know that our next workshop will be on plant genomics and bioinformatics. It will be again 1 month comprehensive bioinformatics workshop in which we are collaborating with EMBL instructors as well as Dr. Avinash is there and as well as our honorable instructors. So the workshop will start from 19th or 20th March. We will share the details soon. So the people working in bioinformatics, plant bioinformatics, genomics will they can have that workshop. So this is a little announcement. So, sir.
Yes.
So any recommendation from your side for our upcoming workshop?
Yes, of course. I mean, all of you guys, those who are definitely working in plant side, they will be. It will be great for you to join that course, and there will be lots of people who are expert in different domain. I will be, of course, there, but there will be other people who are expert in their domain, and they would definitely solve lots of the quick research query that you guys are working on. Okay, so of course, I would strongly suggest that if you guys should join that workshop too. And for tomorrow, I was just writing in the chat box that tomorrow we will see the pre-processing data code in bit detail. Okay, so even if you did not understand, don't worry, we will see it tomorrow.
So
can I see it in your website?
No. Not it's not today. We have not released the details. We will release the flyer, workshop schedule, instructors, everything in coming 2 or 3 days about next workshop. So we will share this information to your mail, to WhatsApp group. And there is one gentle request: please follow our Twitter account. And spread our idea of affordable bioinformatics education to all. We want that more and more people connect with us and benefit from our affordable bioinformatics education program. We are claiming that we are the most affordable bioinformatics education program throughout this world, providing almost 1 month comprehensive bioinformatics workshop in just ₹1,200. So please follow our LinkedIn account and Twitter account so that more and more people get benefit out of this. So with these words, now again I thanks for wonderful session of Dr. Avinash. People like Dr. Avinash are helping us to further our cause of affordable bioinformatics education. Thanks, sir. And with these words, now
okay,
I see
just a last announcement that once you get the code for today's session, you run it and make sure that at least that part is working fine. You are getting at the end R square of 0.80. Okay. The rest 3 pre-processing step, we will see it tomorrow in detail, because I just want to finish few things like logistic, and I will finish it and with the same process data, and then we will see these 3 pre-processing step in detail. Okay, code is successful, great. I'll suggest some study material at the end of the session. Okay, so we are not ending right now. I'll suggest you that. Okay, Praveen, now we can end the session now.
Thank you, sir. Thank you for your session, sir.
Okay.
I am ending today's session.
Okay. Okay.